You know, frankly, you know, we've got a model of Puget Sound and model of Lake Washington. You know, high resolution, multi-beam data, all available, just sitting out there for free. It's really pretty sweet. Same thing with San Francisco Bay, San Pablo Harbor, and the Delta. Just a lot of data available. You can just get access. So don't go out, you know, collect a whole bunch of data initially. First thing is go out and see what's available. I'm sure you guys do that. Now, metadata has been a struggle for a long time. The NCDC has collected data, of course, managed and assembled data sets for a long time. But I mean, I guess because I've been in the business so long, I've been basically modeling for 37 years. You know, so I've seen a lot of changes to the way that they manage their data, the way that they've managed their data, the way they've distributed their data, the way they've formatted their data, and then parameters come and go. You know, you had a parameter, you locked in, you thought you knew what you needed, and then, you know, next iteration of data stations, they changed it. But nonetheless, you can get a lot of good information. There's some databases out there for historic data from these different sites, and it's like you download a year. Some of these databases, I think it's this one down here. No, it's this one up here. I think that this one here is you get like a whole month's worth of data for every station in the U.S. or every station in NCDC. So you have to know the station number. There's no names. It's just this raw listing of data, you know. But if you've got the station number, you download it, search on your station, find it. You've got 744 records of high-quality metadata. And quite nice. Of course, you have to then write a bunch of routines to read, extract, and interpolate or interpret that data. But for the most part, we're not really getting into it because on the temperature side, but you know, the data is generally there. Solar radiation is missing from that data set, though. So there's no measured solar radiation in this particular data set. And there's no cloud cover component. However, cloud cover can be is computed. We have an algorithm. Other people have different algorithms for taking sky cover, where they talk about scattered at 10,000, broken at 5,000 kind of descriptions, and convert that into a fractional cloud cover that's used in EFDC. So you have to convert that into a usable cloud cover format. But then you've got to find, you know, solar radiation from some other source.
National Solar Radiation Database.
National Solar Radiation Database. There you go. So anyway, you have to merge all these different data sets, and right now there's really no tools in EE to do this externally, other than just manually kind of put stuff together, loading them in spreadsheets, cutting and pasting in columns, etc., and making it work. But it does work. And anyway, but I mean, a robust amount of data. It's really quite amazing what's out there. That climatological data set also has wind speed with direction in there, and so you can get your WSER file and your ACER file information from these data sets. But yeah, if you guys know some others that some good data sources, so let me know.
There's something that kind of a coworker of mine came across. It's mesowest.utah.edu.
What's that?
It's mesowest.utah.
Oh yeah. Actually, I've seen that years ago. Forgot it. Not years ago. That would probably just be like a few months ago, and I already forgot it.
Yeah, I use West a lot.
Okay.
pretty good. And it does have solar, depending on the station.
You said Meso West?
Yep.
There's a Mesonet stations as well, used in South, like in Alabama and Gulf of Mexico region.
Good list, good points, Lou. We'll just keep adding to the list. That's appreciate that. Any others that you can think of?
Use the reanalysis data.
The NOAA's CFSR.
Yeah, it's like the national. It's an interesting. They take all the data like over the whole world, and then they kind of model it and create it and come up with basically anything you could possibly ever think of, all the way back to like 1800s. They spit it. Depending on how you want to get it out, it's really easy to get 6-hour average data. But I've used it to fill gaps, and sometimes it's kind of a...
Is it NARR?
Yeah.
That's the American Regional.
Cool.
Yeah. Make a note.
That's great. Okay. So from this, we're going to transition now from kind of what EFDC Plus can do to, okay, how do you do it? You know, some of the tools that are available, and then, see what time is it right now? It's almost 11. I don't know that I want to get all the way through this because there's a lot of pieces to this. Maybe what we'll do is we'll just get started on this, and then maybe we'll jump into some hands-on, do some things. That might be even before lunch. So let's just see how this goes, and we'll take it from there. First off, just kind of some big picture, some things that, you know, needed for a lot of different models, but kind of where do you get it? So you control wetting and drying, as many of you know. Here with this this flag here, going to basically simplify this. We need to be simplifying it for a while. There's no need to have, you know, a minus 99 and a bunch of other options here, because it basically all boils down to turn wetting and drying on, turn wetting and drying off, other than the dry depth number, which I do think still needs to be there. That's it. But right now there are several options that are available. When you put your mouse over it, it gives you a description of what some of these options are. Now, it also depends upon if you're 2-time level or 3-time level. 3-time level, you only have one really option that works. Everything gets kind of, no matter what value, if it's any value other than 0 there, the 3-time level solution will you know, apply the same wetting and drying algorithm. Now, the negative in the wetting and drying term has traditional and legacy applications dealt with what they call the cell skip, where it computationally eliminated cells that met the cell dry criteria. But if you didn't have a negative, it didn't skip. Well, with EE8, that's no longer true. Basically, EE8 has just kind of thrown out that general approach, and I think has taken a more, you know, robust, complete view of wetting and drying. If a cell is computationally dry, it's always skipped, no matter what, in all the routines. However, there are things that happen that you have to account for. For instance, if a cell is dry and you have ice cover, what do? Well, it's important to keep ice. The cell is dry, but the ice is not dry. You know, ice is it's still melting. It still has heat transfer. And if you totally turn it off, all of a sudden it's summertime and the cell wets up and the cell is still iced. Well, that doesn't make any sense. So there's variations to that. Solar radiation, kinetics, some processes have to be managed, maybe not computed it to the robust case of a full open water condition, a wet condition, but have to be managed. But from a user perspective, you should basically just have on or off. And we just, our default that we just recommend everybody just use -99 for now until we just make it a button that says, or a checkbox that says turn it on. Dry step, really explain what dry step does. The concept of a dry step, it's dealing with isolated wet cells. If you've got a wet cell, the cell has depth greater than your dry depth, and it's completely fully surrounded on all four sides by dry cells, but it is wet. It will keep that cell wet for a certain number of quote-unquote dry steps, and theoretically, then if it was still isolated after the 16th time step, it would flag it as dry, even though there was still water in there. That leads to all kinds of, again, the same issues. You got kinetic issues, heat transfer issues. This option is going to become a checkbox too, where really the only question is, how do I handle that water? Do I leave it there wet so it's going through whatever kinetic and heat transfer processes needs to happen to that cell? Or do I, what they call, waste it? I make the assumption at the end of this step, if it's still isolated, that all the water in that cell has disappeared, either through evaporation or infiltration or something. So really that's the question. So, wet and dry, yes or no? If you turn it on, what's the dry depth? And then finally, do you want to waste isolated, water from isolated cells? And that's really the extent. Yeah, Mike.
Now, if you have a very large area that is isolated,
right,
but you don't want the water to be
right, but it has to be a single cell. All four faces
single cell. Okay.
Of that particular cell has to be isolated. Not if you got just two cells connected, they'll never go dry because it won't apply.
Could you go over the idea of wasting? Wasting's just going to get rid of all the mass that's in the cell.
Well, the water essentially disappears. It's actually, from a mass balance perspective, it goes into a QD waste bin. So later, if you're trying to do mass balance, now EE doesn't store that. That's all internal to EFDC. So we were talking about this a little bit about conducting mass balances inside EE or in EFDC versus in EE. Well, EE is limited in its mass balance feature. It does some, crude, kind of high-level mass balance, but because of all the processes and the time step at which those processes are occurring, really, if you need to do mass balance, you need to do it inside of the EFDC. And we haven't really covered that, but probably worth mentioning. Getting back to what happens to that mass, that water just disappears. Any concentrations that were in that water, gone. Now, if it's solids, and the solids have settled to the bottom, they're in the sediment bed, they're not in the water column, they're maintained. Nothing happens to that mass. But anything in the water column that is quote-unquote wasted, the water volume is wasted and the constituents in there are wasted. Wasted in the sense that they disappear.
And that's when that dry step has a negative value.
That's when it has a negative value. The reason why it doesn't really make any sense, it doesn't really apply anymore, because the idea was that after this number of time steps, it would treat it as dry. But we don't ever do that anymore.
So
it's always, well, no, it's not always wasted.
Okay.
It has to be negative right now for it to be wasted. but essentially it ignores it if right now in the EE8. So kind of there's some legacy stuff that just kind of has to be cleaned up and kind of move forward a little bit into more of a streamlined, robust approach.
What happens, let's say in this case, after 16 steps?
After 16 steps, actually, all it does is reset the counter and start counting again. That's all it really does. So in this case, for EE8, it's going to do absolutely nothing. But if it's a negative, then it does get used. Coriolis had some complaints from various people about the way EFDC computes Coriolis. There's not a Coriolis factor in the X and a Coriolis factor in the Y. There's a single Coriolis factor that's applied to both equally to the X and Y. And the only thing that affects its overall rotational effect is model grid size, and size of the domain. And shoreline, bathymetry, all those things affect it. But this is a single parameter, and it's basically calculated from your latitudes.
Is that the middle of the...
Yeah, middle of the model domain. Yeah. And it's a simplistic approach, but that's how it's computed. And what you do in EE is you just, by default, it's using the latitude at the model domain centroid, but you can provide your own value. Just type it in there, and it'll calculate what the Coriolis factor is, and that's what goes into the input files. Well, I didn't really talk about this, but that's probably worth a brief mention. Ramp-up options, because coastal systems, can be notoriously unstable when you're starting up the model. If you've got these open boundaries and they're deep and different things. The standard option for a full model running with no kind of special conditions would be timing is not used and the buoyancy factor is 1. I mean, essentially, this buoyancy factor in here is kind of a legacy testing tool left over. I mean, I can have salinity turned on, temperature turned on, and I can set my buoyancy factor to 0, and density will have no effect on the model, even though I have salinity and temperature in the model domain. I can optionally put in a buoyancy factor of 0.5, and essentially density only has half of the effect that it would normally have. But I mean, it kind of like doesn't make any sense. It's really, it's kind of it's a testing tool, and I use it when I'm doing some diagnostic work. I'll set the buoyancy factor to 0, just to look at impacts without density. But it should be 1 pretty much all the time. It's not, you got to have a strong reason for it not to be 1. And then the timing here, you have 2 options, and we can look at it when we actually have the the tool loaded up. You've got an option where you're modifying the let's see, I'm trying to remember. One of them is it calls it the linear processes and the nonlinear processes, and I'm trying to remember the specifics right now, exactly which ones. But there's 2 ramp-up periods, and what they are is you tell it how many reference periods, and typically on a coastal system, a reference period is a 24-hour period. How many reference periods you will allow before you are fully solving the buoyancy and the momentum equations for that linear and nonlinear case. You got it right there? Yeah, so the number of reference periods to the full buoyancy the number of reference periods to the linearized solution, and then the number of reference periods to the nonlinear solution. And basically, they're affecting the momentum exchanges and calculations. But the concept is that if you want to, you could start up with everything, essentially density having no impact on the model. And then within a day or 2 days, incrementally increasing the influence of buoyancy until it gets to the point where you have a full, the full dynamics. And the only point of these is to just help that model start up. But I can tell you right now that the bigger issue is making sure your water surface elevations match your open boundaries. That's probably the biggest initial condition issue that you're going to run into. But if you're still running into little issues, and you can use these to kind of help get the model cranked up. And then, of course, once it's cranking, you can always create a hot start file and use that as your restart. Okay, moving on. Winfield. With EE8, we've completely revamped the way you apply, not so much the Winfield inside of EFDC, but how you build your wind weighting capability. If you only have one station, it's really not an issue. I mean, you got one station, it's going to apply to 100% to all the cells in the domain in the sentence. But as soon as you have a second station, things begin to change. And the way EE is working and handles this now is that when you're looking at the time series editor for winds, when you're looking at a particular station here, when you click on the Show Parameters button, it brings up this information here, which fundamentally these 5 numbers here all refer to where the station is. So you've got latitude and longitude in decimal degrees. Then you have your UTM coordinates associated with that. And an important consideration, EE, and EFDC Plus, it's done this for years, but EFDC, GBC, assumes that whatever winds are coming in or that have already been converted to your 2-meter height necessary winds for all your calculations. But EE allows you to specify an anemometer, which then it adjusts your wind speeds according to the Z0 log log distribution for your wind profile. So you can change, if you change your lat long and hit OK, it'll ask you, do you want to update the UTM? If I change the UTM, it'll conversely ask me if I want to update my lat long. These generally are at the actual location of where the data has been measured, but they don't have to be. This is just a station coordinate that EFDC Explorer will use in calculating wind weighting. If you want, move it around to where, if you have a particular reason, you can move it to closer to the domain or further away or whatever. But it's just a coordinate that EFDC Explorer will use as it's building the wind weighting process of the wind weights. So this is if you are getting to say, well, let's go back here to this right here. In this particular example, this is the Sydney Harbor project. There we have 4 Met stations along the Sydney Harbor that we want to have an influence on wind speed, wind direction, and temperature simulations in the model. So these, you click on the wind weighting button from the EE main form, and it brings up this form here. And what, by default, it's going to start off with the entire simulation period. That's what it's going to look for initially. And then you have control over what's your inverse distance power that you want to apply. The number of maps refers to essentially how many lines we have down here, and they basically can correspond to differing data collection periods during the period of your model run. So, in most cases, the simplest case, which is what we have here, we have 4 meteorological stations. They all have data that cover the model runtime. So there's one map shown here. However, if for whatever reason North Head only had data for half of my data collection period, but I wanted to keep it in because I felt like it added value to the modeling process. If I click this button here, Generate by Time Series, it'll go out and look at all the data, your period of record that you have for each of these different stations, and build a set of maps based on where data is actually available and where it's not. And if let's say the first half of the simulation period North Head was available, but the second half it wasn't, this would show up as going from like 700 to let's say 900, and these would all be 1, 1, 1, 1. These are a quality index. I can put more weighting on one station than I do on another if I want. This doesn't have to be 1. This could be 0.5 and 2 and 4 and then 1 again. Doesn't matter. It's just a relative weighting of each station. But then the second line would be 900 to essentially 1100. This quality index would be 0. So essentially, it's there's no data, so you can't really use it. So the quality index would be 0. And then we'd have 1, 1, 1. So from day 900 and on, you'd have a different weighting across the entire model domain based on this available data and the quality index. So that's what the maps are, is essentially it's a series of conditions based on, it can be based on anything you want because you control it. But if you use this tool here, it'll build it up based on actual where you have data collected and where you don't have data collected. It's all rolled up, summed up into a total, which then goes into the weighting process, and it's actually described in the little help. New features guidance as to actually how we calculate the final weighting. The final weighting looks like this. In this particular case. So here we had one map, and here's the 4 stations. We have Sydney Olympic Park, Fort Denison, Wedding Cake, and North Head. And so this is, of course, the water body. This is the Pacific Ocean out here. This is the coastline here. So the inlet or the mouth of the Sydney Harbor is right here. And you guys saw the nice little 3D animation as we flew through the. Some of you guys have seen it. I forgot who was all here.
Only Mike was
here. Only Mike was here. We should stop and just show him. Yeah, it's using the 3D fly-through tool in EE. We have a fly-through Sydney Harbor. But anyway, so you can see the weighting. And we're using an inverse distance weighting of 2. You can make it 1, 1.5, 3, 2, whatever you want. Actually, I don't know if it's a drop down. It's basically in half unit increments, but still, that's more than adequate for picking what you typically want. But you can see the effect. So Fort Denison is here, and all the cells around here essentially have a weighting of nearly 1. You can read that. It's really hard to read up there.
Maximum of 0.998.
Yeah, it should be close to 1, right near the the monitoring station, and here it's close to 1, and you can see the influence. So this Fort Denison has an influence up here in this arm, but it's down here around 20% or so. North Head's about 20%. If I looked at Fort Denison, it'd be about 15%. By the time you get that distance out, all the stations are all having an influence on it, etc. So that's kind of the excuse me, the effect of these winds on excuse me, on the wind wake, and that's ultimately what gets used. And the same exactly the same process works with the Acer files. So if you have Acer weight, same process that you would go through and apply these relative fractions. So if number of stations, any number of stations, and any mix of data, it's a pretty robust way of calculating all this stuff. Questions? Yep.
So when it goes through and when you make the different maps, how long of an interval does it need to be missing for it to determine?
Ultimately, I think you have to define that. I think you can always manipulate the data and add spurious data. I think it's a day. There's more than 1 day missing, because EFDC doesn't really care if there's missing data from a model perspective, pure numerics. It's going to interpolate whatever value you have to whatever the value that you need in the model. So if I happen to be missing 3 months of data, but I've got I have wind speed on March 15th and I have a wind speed on June 15th, they'll just interpolate between them, which of course makes no sense.
Linearly?
Huh?
Linearly?
Yeah, linearly, correct. Which makes no physical sense in reality. So as you build up this, and as the modeler, you've got to make these kind of decisions. Is that a gap or not a gap? And my recollection is that it was a day that we used as the criteria to declare a gap. But again, it doesn't use that gap unless you press that gap button, and then it'll build it for you, or you can manually build it yourself.
One more smaller general question on wind data. Do you try to, because wind data tends to be all over the place, do you need to smooth it?
Yeah, it's all over the place. No, my personal feeling about wind is that actually, if you can get wind data to the model on a 15-minute or less basis, you're better off. Hourly winds, and also it depends upon how your data is collected. If it's an NCDC, or a National Weather Service collected data set, with all the modern telemetry, it's an average value for the hour, and that's okay. But I prefer driving it with actually shorter term and letting the model respond to those shorter term perturbations. But yeah, it's frequently just all over the place. Very not random, but nearly random. And certainly at low wind, it is random. It's just eddies floating around in the atmosphere. Yeah, you could smooth it, but I wouldn't necessarily. Just make sure unless it's instantaneous. If you've got some site-specific data collection, somebody's collected data, and it's an instantaneous wind, unless it's pretty frequent, it's almost useless. It has to be averaged. Some high frequency data collected and then averaged into some reasonable time step.
So if you're on 6 minutes, that'd be
a 6 minute average or 6 minute instantaneous?
6 minute average.
Yeah. puts a lot of data, but it makes no computationally doesn't make any impact on the runtime. Files are bigger, but it's a pretty minor issue. Okay. Let me think here. So this is the the primary form for defining open boundaries and linking cells to the various forcing series that we need. And of course, like we've already talked about, the major options here: elevation separation and elevation specified. But this is where you do it. Now, just a quick update on these forms. Everything in this top form, or top panel here, another panel here. This panel here kind of is a global settings, applies to all the cells in a group. And again, EFDC Explorer kind of manages boundaries as logical groups that make sense physically. Typically, that's our approach. So you can have large number of cells that represent a single boundary group. And EE operates on those cells as a group. But there are certain parameters, and everything in this frame down here are on a cell-by-cell basis. So what you can do is, here, let me get ahead of myself. How do we build those cells? Well, you can right mouse click on the domain like we've been doing and just add each cell manually. You can add a cell and remove a cell by clicking on these buttons and specifying the location. But the majority of the time when you have a lot of cells, you have some polygon that you have defined that represents that boundary, and you can just click that button, add by polyline, and it will go out and find the cells that intersect with that polyline and add it to this, or it doesn't add, it actually replaces. So if there's already cells in a boundary group, and you click on the add by polyline, it's not addition to the cells that are in that list. It replaces the cells in that list. So just be aware that it completely replaces those cells. But anyways, this is the quickest way, and the way I always use to assign a boundary where there's a lot of cells. Now, kind of getting back to this cell-by-cell basis. So I have 21 cells built up in this example. As you click through the scroll bar here, it updates this information here, gives you the IMJ, tells you basic information about the cell. Then you have the time series assignments here, and these are on a cell-by-cell basis. So even though it's a boundary group and you're managing it as a single group, each and every cell is uniquely linked to a particular time series. Now, if you have if you want to apply this time series to all the cells in the group, that's what the Set All button does. The Set All button takes whatever settings you have here for the pressure, that's your specified time series of pressure, plus, and this is important, it's a plus whatever harmonics that you have defined, plus your series 2, which is part of this. And be perfectly frank, I don't quite understand, because I've never seen any theory paper on it. I've got the equations in the EFDC, but EFDC has this quadratic variation on the tide series adjustments. and you have to specify a second series, and haven't been able to quite fully understand what it is, but we can import it from a legacy perspective. But typically, the vast majority of times, all you're really doing is specifying a pressure series and a harmonic series, or a harmonic series. And well, I say or, it's and. It can be zero, it can not be used, but anyways, bottom line is, whatever those settings of those two options are, when you hit set all, it will apply those same series and settings to all the cells in the group. The E, of course, gives you access to edit the individual series. And then down here in the bottom, we were talking about those constant concentrations for fluxes. Now, these are group settings. Again, everything set down here applies to all cells in the group. So you can't, in EE, you can't have each cell in the group be connected to a different concentration series. You have one series, all the cells in the group. In EFDC, if you look at the actual input file, you can do it on a cell-by-cell basis. But to me, that makes no physical. I mean, how many people have concentration data on every separate cell in a along an open ocean boundary? I mean, reality is you never had that kind of data. You're lucky to have some data offshore, let alone every cell. So we think this makes more sense. It makes it a lot easier to manage. So we just group all these parameters down here for the entire group, for all the cells in the group. So here is the specified constant concentrations. And you'll notice here we've got some combinations. We have salinity in bottom elevation. At the bottom of the model, it's 33. At the surface, it's 28. And the FBC will linearly interpolate between those. You'll notice in this particular case, I have no salinity time series, but when it's calculating an incoming concentration of salinity for EFBC, it'll take this, the appropriate depth concentration of salinity from these numbers, plus whatever would have been in the salinity time series. Not used, it's a zero. Conversely, temperature, we're using a zero here, but we're specifying a time series. So these are either or, but they can be both. You could actually use both.
Can you specify a layer?
Yeah, oh yeah. Well, you can't with the constant, but the time series associated with the concentrations are all by layer.
Because you specify for each layer.
That's right, for each layer. So you have to specify them by layer. Now they could be uniform if you want, but you have to have a value for every layer. Number of time steps for smooth transition. It's useful for that not to be zero. This just kind of deals with the concentrations transition from inflow to outflow. Kind of prevent a little bit of instability at the boundary, but if you don't really have instability at the boundary, it's really not going to do anything. But it's just saying how many time steps it's going to enforce before it allows essentially the flows to turn around. Not the flows, the concentration profiles to turn around. So it's I typically put a number in there of 20, just something, just in case there's some little bit of oscillation near the boundary. Now, because, and we're gonna this is what I want to kind of play with here. I don't know if we'll get to it before lunch or not now, but anyways, because you assign each cell can have a unique series. You can, if you had a unique harmonic signal for each cell, you could put that in there and just kind of, that a particular cell would have a particular harmonic, or you had a measured series of maybe extracted from some large-scale ocean model, and you're extracting time series for your pressure. These you can do these all manually and have a separate series associated with each and every cell. However, a lot of times that's a kind of a luxury that you don't have. So, but what you do have is I have a known series at one end of my model domain, and I have another known series at the other end of my model domain. And now I want to build essentially an interpolated series between known time series at either end of my domain. And EE has the ability to build those time series up for you. It interpolates both spatially and temporally to build these time series. And you can reset them and do it again easily. If you maybe you change one end or the other of your series and you want to, or you're playing around, you're doing sensitivity and you're moving one, you have to reset it and then reapply the interpolation process. And we'll play around with that here today. Talk about the constant concentrations. So let's see here. Yeah, just kind of again, kind of iterate some of the user interface side. This is, you make your major selection there with respect to the. I'm not even sure why the slide's still in there, but anyways, where you set the radiation type or specified elevation type. Now, let's talk about assigning some of these time series. Let's start off, we're going to talk about the Harmonic Series. There is in EFDC a option for specifying harmonic coefficients, and then for each station, you define amplitude and phase, and it will internally compute the boundary forcing at that cell. And that's referred to as the harmonic boundary condition. And you can access that directly from the domain tab boundary conditions. So again, all your time series and forcings for your various boundary conditions are available down here in this frame. Or you can access, for instance, I think you guys know this, but I can access under the hydrodynamics, it has a wind tab, and I can edit my wind from there. Or I can just go to this tab and click down here and get access to my winds. Likewise, temperature, I have a temperature time series access here, but I can also access it there. So it's just a quick way to get access to all the information. So the Harmonics tab is available when you're editing a open boundary condition, but here we can go directly to it there. And when you click on that button, it brings up a form that uses the EFDC computed harmonics approach. So this is the equation that EFDC is solving when it's calculating your resulting tide level. And so it is the number of constituents that you're actually simulating. So in this case, I'm only simulating 5 of the principal components of that tide series. So kind of picking up some of the most significant amplitude constituents. I've got 5 constituents shown, so N would be 5. So it's calculating, and H is the amplitude. So, and then this is the speed of the tide harmonic, and then this is the phase. Now, oddly, and I'm not sure why they did. It was done this way originally. All the tidal constituent parameters are all defined in seconds, which is kind of a bit of an odd way to refer to these constituents. Because in fact, if you remember looking at the NOAA website, everything was in degrees per hour or degrees, and that's really every just about any place that you go in the world and you look up these tidal constituents, their units will be in either degrees or radians, or radians per some unit time for the period or the speed here. So you have to convert, and EE even should do this, but it doesn't. You have to convert a corresponding phase that EFDC, or that you look up in the NOAA site, and convert that over to seconds. It's an easy conversion. We have it on our website. We tell you what to do. Basically, you take the phase and you divide it by the speed and convert it to seconds. But you have to manually do that from the website. This probably should change and have degrees here and just allow the user to directly input it. But anyways, that's a different issue. But this works. But importantly, and again, remember that the G kind of essentially adjusts your phase based on your time zone. So it knows your station position, and your phase will vary based on what time zone you're in that you selected when you asked for your harmonic coefficients. But this is kind of a simplified equation approach for your tidal harmonics. It works, and that's what's in EFDC. But if you try to go through a really robust process, excuse me, of duplicating a predicted tide series from NOAA or some other system, you're not going to match up exactly. It's going to be off because it's missing some terms. So we'll talk about, we've got these terms in another tool, but we'll talk about that in a minute. But let's talk about this form here for a second. This is, as I was mentioning, there are some other forcing types using harmonics where you can vary temporally and between the harmonics. And like I said, I have the equations, but I see them in the code. I know what it's doing, but I haven't ever seen the theory or a description or discussion as to exactly why these are there. So if anybody has any documentation on this, I'd love to get it. But typically, we select no variation, and these are then directly, whatever's computed by this equation here from these coefficients are summed up to a resulting tide level. Now, you'll also notice on this form here that there's no Z0. That's an offset because the harmonics are going to basically produce a water level based on essentially mean sea level, because it's an averaging of all those processes. So if you need to shift the results from a harmonic analysis to a different datum, you can do that with the time series, because remember, they're added together. So if I come back up here, just jump back up here, my harmonic series, it could be a robust set of harmonics that essentially produce a time series in mean sea level. And then I could just apply a quote-unquote time series, which is really just a flat line of my offset. So I can just shift the harmonics up or down, base everything into my proper datum. So it takes a couple of steps, but it works fine. So because these your tidal harmonics are global tidal harmonics, and are universal. Maybe global because it doesn't work in the universe. It does work on the world. We have these common names and a common speed, and you can display them in different units here by clicking on these different buttons. You can also click and sort. If you click on the column header, you can sort by speed or sort by name. It just makes it easier to find. So you find your constituent that you want, and you just, when you select it and you click this button here, and it adds it to this list. And then you have to finish populating it with a phase and amplitude. But it at least, gets you that first step to get you your speed kind of nailed down. And it's easy to find, but as I was mentioning before, because some of these smaller, kind of more lesser known, lesser used tidal constituents are not uniform in their naming. It's best to kind of focus more on the speed, especially for those smaller constituents or less used constituents. So I can sort by, as I said, by speed or by name. Add them, and then when I get it built, I can test it without having to save it to the model or do anything. I can just hit the view button and get a display of what that type signal looks like. Now in this particular case, when you hit the view button here, the Z0, there's no time series component added to it. So this is just straight up raw data, so you'll notice that essentially it adds up to a 0 mean sea level. So this is a nice little tool. That way you can just kind of test to see how you're, if you kind of catching the patterns that you think you should have from harmonics that you built. However, as I was mentioning, it's missing some of the coefficients. This term here is missing, and this term here is missing from the equation. And these are computed internally to EFDC Explorer through a different tool. So there's two approaches for dealing with harmonics and EE. One is you use the EFDC supplied harmonic approach and you just give it coefficients and any offsets through the time series. The second approach is what we're talking about now is that we use harmonics, but we build an actual PSER file with computed tide values based on harmonics. And that's this tool here. So you go to the water surface time series form, and then you hit the generate from harmonics button. And when you do that, pops up this form here. And it's similar, but not completely the same. And working on a few tweaks that I want to make to this. But again, you have your list of the, I think we have 244 tidal constituents configured. I think that's the number that we have configured. And then what you do over here is you're specifying the units that you're going to use down here. This isn't the units that EFDC ultimately uses. This is just user input units. The EFDC will, you're going to compute time series actually here, so the EE handles all the units. It just wants to know what the units are. So if my amplitude is in meters, so I enter meters here. If it's in centimeters, I use centimeters there, etc. Phase. Nice thing here is I can actually input phase directly in degrees. Like I said, I don't know why we didn't do it on the other form, but we didn't. We should. And we'll fix that. But anyway, so you put your phase here, and importantly, you also give it the constituent name here, because it's going to use the constituent. It has a lookup inside EE. It looks up what the constituent phase is and knows how to populate your astronomical parameters for the the tide calculations for your harmonics. So again, it's the same basic information: speed, amplitude, phase, the constituent. And then once you have that basically configured, you can view it just like we did before. But over here, because you're actually building an ACER file, I mean a PSER file, time series for this, so it needs to have some basic information. If you just click on that or leave it to the default model time or run time, it basically starts at at the beginning of your simulation, and the series will end at the end of the simulation. Or you can conversely, you have a user-defined time series date range. This is not quite what this time step here should probably not ever be grayed out, because that's the time step that's going to generate the PSER at. So in order to access that, you have to turn that on, access that, then go back over here. But that is the delta T that will be used in the PSER file series.
So the model type that you have specified there, it doesn't read that from.
No, it does. It does. It reads it from the timing settings.
Okay.
It's just saying that's what it's going to use here, and that actually is the default that comes up here by default. But then you can manually change it. But that's exactly what it is, using that tBegin variable and the number of reference periods. Now, also a useful feature is that you have your datum shift, your Z0, right here. So I can shift my harmonic series directly to the datum that I need. And you have offsets where you can shift your time if it needs to be shifted for whatever reason. One of the reasons is that there's no good like daylight savings time component. So you can get your harmonic coefficients in local time, but switching around between local and daylight always causes problems for a lot of different reasons. But anyway, so you can do a shift, time shift here, adjust your timing. Anyways, you get it all set up. You can view it. This is an example where we built the tide series for the Seattle station for about a 30-day period, I guess, and we're comparing the predicted time series from our tool to the actual measured tide at the Seattle station. And basically we're tracking as good as the NOAA predicted tides did at the station. So that's the tool. And let's see, go ahead. We got 5 minutes before lunch. Obviously don't have enough time for any hands-on. Let me talk about the tidal interpolation here for just a minute. Now, this is the Yangtze River model. Here we have, again, our corners. I don't have to worry about it here because this model, there's no southern boundary here. This is all land boundary, or at least as far as I'm concerned, this area is land boundary. Anyways, but I have a north boundary and an east boundary. But the scale, look at the scale, that's 100 kilometers. So, I mean, that's a long distance between these, in either end of the model. And it's a long distance along this path. So, we were able to obtain the tide signal for a node up here in this area of the model domain. We had a tide series for this node and a tide series for this node. And using those, we ended up building an interpolated tide series for every cell along this face and along this face, using the tide interpolation scheme. And it's really, really straightforward to do. I mean, literally, all you have to do is assign a boundary here, series here, a boundary there, and then hit the assign button on the interpolation screen. So yeah, here we're just going to the first station. Well, actually, it shows this. We're going to the first station, and then we link it. Go to the last station, and we link it. And then we interpolate. And you'll notice when we do this, we'll do this right after lunch, we'll play around with this interpolation approach, is that the interpolated scheme, or series, they have a unique name. And that name is used by EE to track whether or not that's an interpolated series or a manual series. There's an I colon, and you can't really tell it here in this screen, but it's an I colon, and that EE will use that flag to recognize that as interpolated. So when I hit reset, it will delete all the series associated with it, with any cell that has a series with an I colon in the name. And this is the result, and then we'll be done, ready for lunch. I just grabbed a series from this cell, which is the red line. Grabbed a series from this cell here, which is the blue line, and it just, of course, it means it was a different series up there and there. But anyways, every cell along this face has got its own unique pressure series applied for the boundary condition. That is tied in interpolation. Any questions before we break for lunch? Great. I did such a great job. You guys are just like no cells around the model domain. So that's why it's 4 bigger in both directions. So there's our quick little Cartesian grid that we created. So now, save this. I'm looking, Janesh, while I'm doing this, looking for the Yangtze time series. I'm trying to remember that model that I have. I'm trying to remember where it is. Oh, wait a minute. Actually, I've got it.
I'm not sure if I have Anxi on my machine.
Yeah.
I can access.
Yeah, see if you can find it real quick. Okay. All right. So let's go ahead and save this wherever is appropriate for you. So we just created a nice, simple little model, flat bottom right now. And so let's go ahead and apply some, shallow but reasonable boundary conditions. So let's we're going to apply a southern boundary, open boundary, and then all the other boundaries will be no flow. So just to start off with, well, we got it here. Why don't we go ahead and deal with the issue? Well, if these are no flows, we could leave this boundary, these corners alone. If we were to assign, we wanted to assign open boundary to some of these cells, of course, we need to deal with that. But since, I guess in this typical or simple example, let's just go ahead and do that one alone. I'm going to set up a model that is has a sloping bottom. So let's go ahead and close that out. Let's go to the Domain tab, Initial Conditions, Bathymetry. Now, this is predominantly for these little quick test cases, but we have some tools here, and one of them is just this bottom slope. I can apply a bottom slope to any model. And again, it's really intended for these kind of simple construction test case models. But I'm going to apply a bottom slope in the J direction.
I just copied that NC model in Dropbox.
Oh, okay, thank you. Where is it? In the Dropbox folder?
Label 2 coastal.
Okay.
Yeah.
Okay. That's good. All right. Now let's see. Actually, what I wanted to do. Oh, wait a minute. No, that's not going to work because I need the original series. That's what I'm looking for. I'm trying to remember the original 3 series.
Oh, okay.
The ocean boundary for the original 3. Actually, I just need 2. I mean, we could make them up. It doesn't matter, but it'd be nice to have something that was more realistic. So, yeah, see what you can lay your hands on quickly. All right. So what I'm going to do, let's just set it up. Now, the slope concept is that usually a positive slope is going down. So if you want, and the orientation is it's just directly oriented to the I and J map. So if your J is going, you want it to go up because we want it to go from deep to shallow. You just put a negative slope. So we'll start off with an initial elevation of say minus 30, and I don't know what. Let's just try a minus 0.0005. I don't know what that's going to do. Probably calculate it out real quick, but we'll just play around with it for a few iterations. That's it. It tells me how many cells it just applied to. Now let's look at that bathymetry and see what we just created. Oh, done. So that 005 is a little bit more if I want to use a 0 as the mean sea level. But you can see we're sloping from a bottom elevation of minus 30 meters below the mean sea level or our datum up to 15 meters above our datum. Well, I don't want to go that high, so let's just iterate again. Just change the slope, or drop the bottom, but we'll just change the slope. So that was minus 30, and the slope is minus 0.0001, 5 times, so good bit flatter. So fly, done. Look at the bathymetry. Oh, I clicked the wrong button. Whoops. I left it at the J, so now I'm sloping in the I. J slope. Although if we went up to 9, I don't know. Let's just see. That means still be 101.
Oh, you did it again.
I thought I clicked on. Oh, I know what's
No, when
happening. When I'm
push
hitting
the tab,
tab,
yes, it jumps on that.
it's jumped something. It jumped around for sure because I know I clicked on that. But you're right. It did.
Yeah.
It reset back up to I. So now let's look at it. Yeah, it's good enough. So we're going from minus 30 up to minus 21, so it's sloping up to the cliffs of Dover, I don't know, or something. Something still deep at the coastline. All right, so let's go ahead and save that. Now, were you able to find it?
On 4, create 4 files. 4 times series.
Oh, okay.
These are in Dropbox.
In Dropbox? Oh, I see them, yeah. Thank you.
You're welcome.
This one is just
yeah, that's the extension problem. You can delete
Okay.
that.
Stick them up in the distribution. Oh, that is
already
your
in
distribution.
distribution. Yeah.
Okay. Well, copy it into my project folder so I can find them easier. But anyways, everybody, go ahead and grab this. Should be on the Dropbox folder that you've got. It'll be under Projects Coastal Yangtze Open Boundaries.
Would you let me know his ID and password in Dropbox?
Oh, there is no ID and password. I gave you a USB drive this morning,
yeah.
right?
Yeah.
Can you open that?
Yeah.
You don't need a username and password. Go back to Edmond's training. Click here on Dropbox file. Copy that.
Okay, thank you.
And paste it.
Okay.
You know how we got this cake? It's having from the hotel.
Windows has stopped working. Windows Explorer has stopped working. So I've confused Windows too. Okay. Now. Okay, let's go back to EFTC Explorer. And go ahead and bring up the form, and let's go ahead and create a boundary condition. Well, actually, we need to set initial condition for the water surface elevation, and I haven't set that. So we need to set that. Generally, the idea of this kind of the domain tab is these are kind of like the initial major settings just to kind of get a model set up in order. Bathymetry first, depth second, and then bottom elevation set. But the default value is fine at 0.01 or 1 centimeter. So let's just go ahead and assign water surface elevation a constant of 0. Call that good. For now, anyways. We'll go back to
the minimum height that we specify here. Is it just for the initial conditions?
Yeah, the minimum height term that's in the initial water surface. Let's go back. Think about here. This is the minimum. It goes. This is one of those legacy. That's the reason why it's in this. Whenever you see these, again, this legacy term here, it's kind of stuff left over from old implementations of EFTC. The problem is that we keep them in here because some people use them, some people don't, because what they're used to and things. But I try to keep people away from using these, making any changes to these at all. But this minimum height gets applied at the start of the run. It looks at all the cell depths for the entire domain, and if there's a cell depth less than the specified minimum height, it gets that value. That could be a problem if people aren't paying attention and that height, for whatever reason, is higher than your dry depth.
It shows on.
It's going to show up. It's going to put basically a water layer over every cell, even when they're up on the top of the hill. And then the model turns on, and you get instability because it crashes. All that water that's mounted up on these hills just comes rolling off. Now, we do what we try as much as possible to try to make this as simple as straightforward. So you come over here, the defaults that we apply for everything is a minimum height of 1 millimeter because that's never big enough to cause anybody concern, but it's not 0. An additive factor and a multiplicative factor, these are applied uniform. Even if you don't touch these, EFDC will always use these factors when it's setting up the initial conditions. But we set them up so they have no impact. You know, 0 additive, a multiplier of 1. If you get a model from some other person that wasn't using Explorer, these may not be 0 and 1. There's a lot of different reasons. You could use this to adjust datums, to go from feet to meters, but why? You know, that's my opinion. You know, just keep it simple, keep it the units consistent, and don't use these. But that's why they're there. Don't recommend you use them or change them, because these are the most general settings of the game. And EE and EFDC handles everything else from that point. So anyways, that's what the minimum height does. So let's go ahead and create a new boundary condition group. So we go to boundary conditions, enable edit, and I'm going to create a boundary condition group here. Go to new and create an ID. So this is south. Specify your ordinal direction, which is 3 in our case. Southern boundary. Brings up the form. We're not going to populate this right now for a couple of different reasons. Just say OK. It'll be fine. It'll show up as a defined boundary condition. There are, you know, if you just want to use the mouse, if you only had, say, 3 or 4 or 5, even maybe as many as 10, it might be just as easy to just manually use your mouse to add cells to the boundary group. To do that, the easiest way to do it is use the add to adjacent feature. So if I click on a cell that's near an existing boundary, this add to adjacent option will be enabled. And the purpose of that is just to quickly add a few cells together to build a boundary group without having to go to the trouble of you know, building a polygon and, you know, or a polyline to specify the boundary. So if I hit add to adjacent, you can see it adds it to the boundary group. And then I edit. Now I have 2 cells, and you can scroll through them and, you know, see them, etc. Now, that said, we've got 40. I don't want to add to adjacent 40 times. Too many clicks. So I'm going to go ahead and create a polyline. So let's create a polyline. We'll assign the boundary real quick. So go to the polyline tools, create a new polyline button here, and let's just draw a line through the boundary. And again, all you have to do is, when a polyline is open, as opposed to a polygon, it just the cell just needs to touch that line, and it's going to be included in the list. So notice that here it says that, you know, if you need to provide an ID, and if you don't provide an ID, it's going to delete it. It's just like hitting cancel. So you need to put something in there, and the reason for that is we're P2D files, and most of the P2D, they've labeled the line with this ID, and then when you're doing statistics later, it uses that label and will report the statistics based on the ID associated with the selection. It's just, anyways, bottom line is you've got to put a name in. It can be anything though. So now I've got a polyline created. Turn that off. Oh, I didn't save it. Thank you for reminding me. Now I'm going to save it. You can name it anything you want. I'm just going to say from my perspective, especially when you're working on a bunch of different projects or you're going back and looking at old projects, the more consistent you can name your files, the easier it'll be to kind of track what you did in the past. And
so EFTC is not picky about the format of the name if you put a space or something?
No, it's just a, no, it's not, doesn't care. It's just a standard Windows naming convention, period. So it could be, what, 256 characters long if you want. I like to use this term cell selection for any polygon I use fundamentally to select cells for whatever purpose. You know, for statistics, for manipulation, for boundary condition, whatever. So it just makes it easier to track later. So anyways, just a usability issue. So I'm going to save this. Now I'm going to edit this boundary, and we're going to apply that boundary to polygon using this add by polygon method. Now remember, it replaces, so what should happen? We have 40 cells wide. I already have 2 cells defined. When I do add by polyline, it should only have 40 cells, not 42 cells. Because otherwise it'd be double counting a couple of cells. So I hit add by polyline, browse to the one, and it says either open or closed. Browse to the one that I want, the cell selection. There it is. Select it, apply, done, 40 cells. So now I've fully defined the cells, but now we need to make these connections to the time series. So remember, the approach is we assign, honestly, I was just trying to remember this. Actually, I think this works too. You can assign a series anywhere within a boundary group, and it only interpolates between series. It doesn't actually have to be the endpoints. So I could stick a known series in the middle, and it'll also work. But we're going to go ahead and just assign one on the either end for right now. So we've got 40 cells from on cell 1. Let's go ahead and apply a time series to that. So just come down here, and we're going to load this in. I need initially 2 series. So I'll just select 2 because initially that's all we have. Now in this case, I'm going to use the import data button and bring in the data from that first series that Janesh just provided in Dropbox. So let's click on the browse. I'm assuming we can always look at it. All right, southeast and east ocean. So I think what we want to do is apply. Oh, and by the way, the order of which the cells are built into the boundary group.
I don't find them.
This order is in the order that you draw the polygon. So I drew it from east to west. From west to east. So as I look at the order of these cells, you'll see that they're increasing along my L at the bottom of the model domain. So if I want them in the opposite order, I'd just draw it the opposite way, and it would, the order would be reversed. And as far as the actual boundary condition assignment, it makes no difference from the standpoint of EFDC numerical solution. But it may be logically, as you're trying to manage the boundary, you might want it in a particular order. So that's how you control order. So anyways, getting back here now to the pressure, go ahead and do current series 1, import data. So I'm going to import the, I'm currently, my current, shoot, I'm on the wrong cell. I was playing around showing you what cell it was. Now I got to switch back and switch it to the right cell. Well, actually, no, I don't. Series, I can just go ahead and bring them in now and assign them later. So, sorry, talking to myself. Import, get back here. All right, so I have a southeast and a east ocean. Let's just pick the east ocean boundary for the far left, actually the western boundary. So that's what we're going to select for 1. But when I've selected that, it comes down here and gives me some basic information about what it saw. Preview graph, I can take a look and see what I'm importing with preview. Here, and if it all looks kind of okay, you can you control, well, let's do that actually. Forgot about this one. This is the data column to import. So when you're importing these formats, it's typically the second column. But this is the data. So it's assuming that column 1 is date, or time. So the first column to actually, that's quote unquote, has data in it for the Y value is column 1.
See if east works.
Problem is I make changes and yeah, that's right. So I'm going to import column 1. I can apply conversion factors, etc. We can, if this isn't in Julian time, I can provide shifts, but it's already in Julian time. So if preview, it should look something like this. Now, everything looks fine. Say OK. This was. This has 5 series in it. I don't think that's right. What's that format? Let's look at this data. I mean, that's right. But
yeah, that's.
Let me look at the format of that data here before we.
And he's getting an no active cells found.
Sent to Notepad.
Just right click and open it. It will
Can
ask
I
for
open it
editor.
here?
Oh, well, yeah, you could. Yeah. Just okay. No, you only got 2 data points.
Should I get more?
No, you don't need any more. That's I don't know.
Yeah.
I'm just trying to think. For now, zip up the model. We'll get a model that works. I don't get, and then so you can keep following it. But honestly, I can't figure out why it's not finding it. It's kind of weird. We'll get you. We'll make a few more steps, and then Janesh will give you a copy of his model. Okay, that way you can at least keep tracking. All right. That's what I was. This is just. East Ocean.
Yeah, there's 2 columns.
Yep, just 2 columns. Okay. Mouse versus mouse. All right. Yeah, when I picked the method that I picked for my boundary condition, I picked this. I was thinking it was that format. It's not that format. That format, the header is it starts off with the number of data points followed by the legend ID. And so when I just have a simple data pair, I have to tell it the appropriate, way to interpret that ASCII data, and it's just a date and a value. So I should have picked that one and not that. And then now it should import fine as soon as I reset. Now, there we go. That's what it should look like. That's better. Everybody should look like that. Oh, that's legacy left over from the first time I imported.
Can you show us again how you?
Yeah. Let me cancel. We'll just kind of start over again here. So start off. We need to import 2 series. So because we need one at either end, and these are known somehow, known series from the project.
Where did you get that?
That form that I'm looking at?
Yeah.
That edit button right there,
Okay.
next to the pressure time series button, or drop down. So that brings up this, then I go ahead and I'm going to call it my, even though it says east, I'm just going to call it my west boundary. Now, I need to import data into this field, and I'm going to import this file, which is correct, but I made, the first time I did, I was thinking it was in the format EEDAT and water quality DAT. These are export formats from EE. When I write out a time series file or certain other exported information from the model, it writes it in this standardized format. However, this raw data is just simple time and value. So we're going to import this. Then, because this is a different format from this, it's recognizing that you need to tell it what column to import. Notice here it says data column to import. This is exactly like I've discussed up here, but because it's a different format, now I actually have to tell it what column to import. So if I had in this file, I could have all kinds of other columns of data, and I could, select which column I want to bring in to in the model. So if you don't know what it is, two things. Number one is, as you change this up here, anything here, it updates this kind of like first line of importing and tells you what's happening. So that looks right, and then I can always press preview and see what it's really doing. These are legs that's left over from that jump that I was when I made that first mistake.
Did you already download from Dropbox?
Yeah. Okay.
The cake.
You can use those. Yeah, that's fine. Here we need to change the column to number 2. Hit enter. Preview.
Why is it not showing?
Use this one, right?
Yeah.
Maybe
It works.
okay.
I just closed it and I just closed the FTC and opened it and it worked.
Okay, so you closed EE and then reloaded. So something,
Yes.
yeah,
Okay.
something was weird there. But glad you got it working. Sorry about that.
Yeah, I'll make a note of that. Yeah, it's good. Everyone's trying to do the same thing, and then we'll find out problems. That way, make it more robust tool. So, can I get my back?
Sure.
Thanks.
So what else did you add after
So
the?
it's just
We
pull out
created
another-
2 bracer boundaries.
Yeah, pressure.
Go to the boundary conditions and add 2.
Go in.
All right. Let's move on to the second one.
Time series.
Everybody there? Okay. So say okay. It brings it in. There it is. You can again look at it if you want,
And create
just to make sure it brought it in properly.
use import data. You copy this file from Dropbox somewhere. Anyone you can use east. Yeah.
And we're going to do the same thing to the second series. So I'm going to pick my second series here, change my name. This will be East.
Similar to get another series.
Import data.
Same data.
A different one. Anyone.
Julian date. But now I'm going to pick the Southeast option. Julian date. Rows to skip. Column. Preview. That looks like the same data, but we can check it out here in a minute. Sure it's different. Okay, so now I have two series. Let's see if they're, yeah, they are different. So let's, whoop. If you want to see, you know, you've got all these different kind of plotting tools. If I click on more button here, you can see it kind of hides, covers up with different options. So I click on more, it brings up this, then I can click on show all series, and that way I can see all my series that I want to see simultaneously. It lists them, and then I just press a 1 next to the ones that I want to see, hit OK, and there they both are. So they certainly had the similar pattern, but they're certainly not the same series. So everybody should have something that looks like this. We have a 2 water surface defined series, one for the east, one for the west. The east has the larger amplitude swing, and the west series has a lower amplitude swing. Everybody there? All right. Moving on. Say OK. Now, all we've done is define the series. We've not linked anything. So you'll notice, you know, everything is still none and none here. So I'm going to go to the first cell, which happens to be in my polygon. I drew it from west to east. So my number one first in the boundary group will be my west boundary series. Then I go to the end, and I apply the east boundary series. Now I only have, as I scroll through the rest of them, you can see they're all set up to none. You'll also see up here that there's 2 boundary series defined. Now, I mean, it doesn't matter what this is, but now what I want to do is, if I wanted to, you know, if everything was consistent, I go up to here and hit set all, and it would apply that same series to everything. It's not what we want to do. We're going to use this interpolation option here.
So in this case, if you press set all,
it'll overwrite that last one that we just set for the east, for my east boundary condition. Everything would have been set to the west. Yeah, it doesn't. It just overwrites every current setting. With the settings, with whatever is currently displayed here, gets applied to everything when you hit the set all button. All right, so now let's assign. And it just went out and interpolated the 38 cells in between the 2 that were there. Hit OK. Now, let's scroll through these cells and see what happened. By the way, you'll notice now the number of pressure series currently defined in the model is 40. My first one is west, which is what I told it to be. But the very first next cell over has that I colon indicating to EE that it's an interpolated series. West, meaning that it's 0.026 fraction. I'm trying to remember what the units are of that. But that 0.026 indicates a distance from the west boundary. And it can't be in kilometers, but anyway, I'm trying to remember exactly what it is.
Divided by 38.
Yeah, I think it's
is that
fraction.
Fraction?
Yeah.
Thank you. Quick thinking. So that's the distance from the west boundary, and then as you scroll through them, you can see it just increases from the west boundary. But when you get over halfway, now the east boundary is dominating. It's not, it's not 100%. It's just dominating. And now that we're 0.53, we're still from the west, but it's actually the east boundary is dominating. If you want to see what that looks like now, we can go in and plot. Just do some extraction of time series. So let's pick up this cell. We view the cell. Remember, view group. And when you're dealing with open boundaries, view group is focused around trying to compute the flow from an open boundary. But you don't have the flow until the model runs, so it's more of a post-processing feature. But view cell will actually display the imposed time series elevation series. So if we do view cell, oh, I haven't set the model up. It's viewing it for the model runtime. Well, we haven't set runtimes up yet, so we need to jump out here. That doesn't affect the the work that we just did, but it does affect the plotting. So let's come in here under timing and go through the process. This is really the reason why it'd be nice to do some of the stuff automatically. Model metrics, what's the CFL? CFL's 200. That's why I'm just going to use 200 seconds. So I can use a 200-second time step. Run it for a day. Run it for 2 days. Time to start at 0.
That starts at 180.
Oh, the last data stop?
Yeah.
Oh, it starts, that's right. It
180.
starts at 180. Right. Thank you.
Yeah.
So we'll just do it that way. So
34 days. The data is available for
yeah, it's available for 34. I don't know that I want to run it that long.
Right.
But anyway, so let's just get it running here for a couple of days. Now, when I go, let's just save it because we've made a bunch of changes. So now I'm going to go back into the boundary condition, and when I view, it should display the boundary forcing for the period of my simulation. When you do view boundaries inside EE from the 2D plan view like this, it always by default just plots the period of the run. You can see the entire boundary. You have more control of that when you're in the individual boundary series section. But here it's just going to focusing on the runtime itself. So there's the series for 3.3. I'm going to write this out, export it, so I can bring it into another series. Because with boundary conditions, you can't add, if we were extracting time series for water surface elevation, I could just click and add and click and add and click and add. But when you're extracting from a boundary condition, it doesn't do that. You have to, if you want to bring in and compare boundary condition series, you got to do that manually. So we'll just export this to a file. It's going to default to the group name for the boundary condition. So I'll leave it at the group name, but this is going to be my west cell, and I'll write it out to the ad hoc analysis folder. So that's available. This data has now been written out to a file that I can then bring in at any other time. So let's just pick something out here in the middle. View cell. Export that to south. Something mid distance across. And then finally the end. And I could This will be east. Now, I want to look at how this one compares to the others. So the first thing I'm going to do is bring in the far west boundary and compare that to my current boundary. And they should be, of course, what we started with the interpolation. So that'll go into line 2. Pay attention, by the way, sometimes when you're importing or doing things, it's asking you just to use a flag, 0, 1, 0, 1, 0, 1, to select. But when you're importing into a series, you can actually overwrite existing series with this. So it's asking you the series index. So this is already taking up line 1, so we're going to bring it into line 2. So I'm going to specify line 2. So there's my second series. And now I'm going to bring in the mid-depth, or the mid-distance series into line 3. So now let me change some colors and formatting so it's a little easier to see. So let's make this, that one is the east. Make that, whoop, wrong button. That red. And this one blue. And we'll do the mid-depth green. So there's the interpolated series. I mean, it's really easy to do these series. You just need to have something that you can define your bounding series on. I'll save this out. And I'll save, I exported the data, and I'm also going to save the format. So, the default is DSG, so if later I want to bring up something that, a plot that looks just like this or real similar, I can just load up that DSG, and all my labeling, colors, and everything will all be set. Now, that pretty much sets it up for us, but this is going to be interesting because we have a varying initial condition. So click on the cell and notice the head. So initially what it's saying is that it's going to start off, that cell, the initial water surface elevation at time 180 is 0.48 meters of head above datum. Far end, minus 0.009. So, and then mid depth, 0.29. So there is a water surface slope in this example, sloping there to the east. So if we want the model to, I mean, it probably would start up. It's not going to be dramatically off. But let's go ahead and do some, let's build a water surface elevation initial condition that somewhat mimics the tidal initial condition. So we know here that it's 0.48. So I'm going to create 2 points. One point that represents the east elevation and west elevation, and one that represents the east elevation. And I do this, for simple models. This works really slick. You just use the model extraction tool, and we're going to create a set of XYs, and then we'll edit that file, and then put it in the elevations we want. So, bring up, use the mouse to extract the points. You can, of course, load in existing XY files or IJ. We're just going to use the mouse. So I'm going to pick a point here, pick a point over here, and call it good. Turn it off, save it out. Now, I'm going to go ahead and select that. But right now, actually, what's in that file is not water surface elevation. It's kind of nonsensical for what we need. So just remember, 0.48, and, or, yeah, you guys remember, so you can tell me, because I won't remember. 0.009. So come in here to domain, assign water surface elevations, use point measured data, and browse to that file. But however you guys want to do this, I'm going to go ahead and edit it here. And change this, these parameters. This was 0.48 and -9. Oh, too many zeros. Okay. So I've just assigned an initial condition. Just change this to elevation IC. And you can see the asterisks. They're just you can have as many in these kinds of DAT files. They just indicate a comment. They can be interspersed in the middle of the data. It makes no difference. If EE finds an asterisk in the data set, it just assumes it's a comment. So that's set. I save it. Now I can bring it into my file here. I'm using point gridded data. I'm not checking this because I actually want elevations assigned, not depths. Hit apply. Done. Let's look at the water surface elevation now. So it's sloping from 0.48 to minus 0.09. Okay. We're basically ready to go. I'm going to run. Save it. We have the timing set. We've got initial conditions set. We have boundary conditions set. We'll turn on salinity next. Okay, because actually I want you guys to get started on Chaku, so I want to kind of get past this quick. I just want to do a quick run and then we'll move on. Save. I did say this already. Run it. Linkage frequency, 30 minutes, 15 minutes, something. You know, you kind of need to tie this to what you intend to post-process to, and the length of the period of your simulation. Because obviously, if you output frequently and you run a long-term model, the files can get big. So it's kind of a balance. And as far as this goes, change that. That looks fine. Go.
Can you show the water surface elevation again?
Yeah.
The file.
Let's get this up.
I think the only thing it changed is the last two values.
Yeah, I didn't see the values.
It's 0.48 and minus 0.009.
In my case, it's different, right?
0.
Well, it will be a little different because I wasn't exact on my clicking, and it's just interpolating between the point the point values where you actually clicked. So if you're a little further to the east or west than mine, you'll have slightly different values, but it should fundamentally be the same.
Oh, did you also change this?
I changed to 0.48. I mean that's what, and that was minus 0.009.
Assuming you're using the same series.
Oh, 0.9. One more zero. Mm-hmm.
Do you have 200 here?
And yeah,
Yeah.
mm-hmm. It should. Elevation. Yep, there you go. somewhat a trivial case, but what we'll do here just real quickly is just kind of look at the title. Here, I'm going to set the timing frame up so we can see it. What the tide's supposed to be doing. Let's make this the west. Well, actually, now this is the boundary groups here. The intention of these annotation groups is not to be real robust to every cell plotter. It's just an indicator. So from the standpoint of a timing frame, it's looking this as the south boundary, not every cell on the south boundary. And then secondly, when it extracts this, it's just going to pick the first cell in the group and plot that. It's really what you're seeing. So we'll just leave it at this, hit OK. So this is what's happening at the boundary conditions so we can see the direction. Let's turn on the animation and just kind of watch it, what's happening as the tide. You can see it that kind of, a wave as the tide kind of propagates down the boundary. And anyways, obviously we can keep adding complexities and stuff, but I'd rather do that with a more realistic model, the Chaku. So with that, any questions on interpolations? Did everybody get it working? Oh, one last thing I want to talk about interpolation, which I think this is important to note. Go to Domain tab, Boundary Conditions, Edit Review. There's our south boundary, how many cells, etc. I'm going to double click on that. As we scroll through, again, we talked about this I colon. Well, let's say I change something. I change either the east or the west boundary, and I want to reapply it. First, I just hit reset over here, and what that'll do is it deletes the association of that cell with the interpolated series, and it deletes the interpolated series. So right now there's 40 series currently defined. I hit reset, yes. It removed 38 series from the series file, as well as decoupled them from the individual cells. So now they're now unassociated again. And then I make a change, do whatever, then I hit assign again, and it's done. Just that quick. Okay, so with that, we will swap out computers.